Hello and welcome processing users to part 2 of 2 in this tutorial two-parter series on the pixels array in processing. If you did not watch the first video and you've never used a pixels array before, please don't start here. Please jump back to the first video because this video is going to assume that you at least have a basic grasp of how the pixels array works. So if you just recently watched the first video, we essentially drew an image on the main canvas in void setup, and we loaded the pixel color information in that was drawn on the canvas at that time, and then we were able to both extract and essentially read individual colors at certain pixel locations, as well as write new colors at specific pixel locations. Now in this example, we're going to take this one level further and talk about a more powerful and flexible way to use the pixel color information in this coding environment. So this is the starting sketch we're going to begin with. If you're doing this yourself, please go grab a JPEG from online or one that you've taken yourself, and we're going to be scaling that JPEG down to be quite small. So remember, if you're ever in processing, if you're on a Mac, you can hit Command K. If you're on a PC, Control K, and it will actually let you jump into the folder where this processing sketch is saved. So the sketch is called Pixarray. I'm inside the Pixarray folder. This is the data file, essentially the text file that holds all this text here. And then the data folder shows any pictures that you might have imported or just quite simply dragged into this white code editor window. It'll automatically make a copy of it for you and drop it in the correct location, which is really nice. So here's the picture. It's called wc.jpg. It's a watercolor I found online. If I were to go look at this image, hey, 4 kilobytes, that's tiny. Why is it so small? Well, it's because I've scaled this down so small to be 100 pixels wide by 56 pixels tall. Why does that matter? Well, I'm actually going to need those dimensions. If you use your own picture that are of your own dimensions, please do write down what those numbers are, or if you have a good memory, store them in your good memory, okay? Because we're going to need to write those down in our code. So mine is 100 pixels wide by 56 tall. This sketch is doing nothing really particularly new or exciting other than making a P image. It's loading that P image up in void setup, which is a very common thing to do. And then in void draw, we have just a white background. Just to make sure the picture is working, I could always say image and then ref and just draw it at 0 pixels or 100 pixels over 100 pixels down, just to make sure that everything is okay. And yeah, okay, yeah, there's my picture. Fantastic. But what I really want to do is introduce a brand new idea, which is that I'm using a tiny picture because I don't need all of the, thousands or sometimes hundreds of thousands or millions of pixels in a picture. I need actually very few pixels, but what I really care about are the colors inside of specific pixels in a picture. And my main goal is to be able to kind of extract those colors out and to draw bigger shapes or text characters or other visual elements on the screen and have them adopt the color information from my source picture. So in order to kind of get into this, I would like you to add a new data type that perhaps you haven't used before called p-graphics. You can think of p-graphics as like a visual layer that's separate from your main canvas layer. It's really convenient because it can be of a different size, which we're about to do. In fact, when I make this new p-graphics layer, I'm going to call mine mini because it's going to be miniature. And in void setup, I want to say mini equals create graphics. Okay, this is an important part. And you're going to put in the dimensions of your tiny picture. 100 pixels over in my case, by 56 pixels down. Okay, so that's just saying it's going to be this small little mini canvas, if you will, a miniature layer. And what's interesting about these p-graphics layers is you can treat them like an image, but you can also do different things to the p-graphics layer than you are doing to your main canvas. So it gives you a lot of freedom. Now what's interesting about these is whenever you are going to make changes to this layer, we need to use something called begin draw and end draw. This is almost like saying, hey, I'm going to crack open this layer and make changes to it, and then when I'm done, I'm going to signify that I'm done with my changes by saying end layer. So let's try it out. Mini dot begin draw. Okay, and before I forget now, I'm just gonna just finish this out. Mini dot end draw. Why? Just so I don't forget. Okay, maybe I'm a forgetful guy. So I've got a start and an end, and what that really means is in between these two is where I might make changes to this little kind of cute little layer that I have. So what am I gonna do? If I'm ever gonna make changes to the layer, I'm gonna refer to the layer first, so mini dot, and at this point you have all the same options that you would normally have if you were just drawing right in void draw or in a canvas. So you could say rect for a rectangle, you could say background to change the background. Pretty much everything's up for grabs, which is nice. What I'm gonna do though is I'm gonna draw an image, and that image is gonna be of my flower. Remember, my flower is called ref, so I'm gonna draw ref at 0, 0. Okay, so now all I'm really doing is I'm putting that layer in the top left corner of my pgraphics layer. It turns out that ref is the same size as my pgraphics layer. Great. Now, just so you know, you can always draw your pgraphics layer in void draw if you want. You just have to make sure that when you added your image, you had the begin draw and end draw. So in void draw, the main part of our looping program down here, I'm going to say image, but I'm going to put in the name of my pgraphics layer, which is just mini. And where are we going to draw it? Well, shoot, let's draw it at mouse X and mouse Y, so it's kind of stuck to my mouse position. Okay, like that. Let's run. Okay, yeah. So it's just, right now, it's acting like a tiny little picture, because it is a little picture. But what's nice about this is it's a picture on its own layer. To prove that to you, I could always say, well, fine, I want to say mini dot ellipse and draw a big ellipse at 50 pixels over, 50 pixels down. That's 100 pixels wide, 100 pixels tall. And now I'm going to just run that. And what do I see? I see a picture, but I see a big white opaque ellipse on top of the picture. Does that make sense why we're seeing that? Yeah, it kind of does, right? Because I'm just like adding multiple things to this little baby layer. Now notice the baby layer and the ellipse that I drew to it are getting cut off, and specifically the ellipse is. Why? Because I'm having the ellipse draw at a location where it's falling off of the whole scene, right? Why? Because it's just this tiny little canvas. So just so you know, like we don't really want the ellipse in there, but just so you know, it's a little bit different than drawing just a picture because you can essentially do as much as you want to it. But going back to the pixels array, guess what? I can do load pixels on the mini pgraphics array. The advantage of this is the pgraphics array is tiny, the picture is tiny, and therefore we have relatively few pixels to deal with, which in this case is kind of a good thing. So remember, anytime you load pixels, you do it after your visual content is drawn. So I'm doing it after the image gets drawn here, and I'll say mini.load pixels, open close parentheses. Simple as that. Now before, whenever we wanted to access the pixels, we could always say pixels, open square bracket. We can still do that, but now we would just say mini dot pixels and then open square bracket and then the number of the pixel that we want to grab the color information from. Okay, so what's interesting about this is, remember, we did a begin draw, we end draw. So as of this point, we're not editing the mini layer anymore. Why? Because the end draw is done. But I'm still in void setup, right? My mouse is still inside the closing curly bracket. So let's do a print line. And I want to make sure things are still kind of what I think they are, right? So first of all, can I still access the pixels array using mini.pixels? Let's put it to the test. A good way to find out how big an array is, you can always say .length. That's a property of any array. How many items are in the array? I'm going to hit stop and play. If the array didn't exist, it would just say that doesn't exist, big red error. But no, in fact, it says 5600. Wait a minute, 5600, is that right? Yeah, it's right, because 5600 is 56 times 100. Therefore, if you were to take that many rows and columns of little rectangles, or in this case, pixels, you would get 5600. So that looks right. I could also say, okay, fine, what is the 2169th color. I'll run that, and processing will not very helpfully say, oh, that's, negative 129.2477. Well, that's not a very human readable number, but we kind of talked about this in the last tutorial. I could actually just extract even from that something like, well, how red is that? You can put red and a color inside of there, and it'll give us the 8-bit value for how much red, right? So it's 233 out of 255 levels of red in that, right? The amount of green, give me a different number, 71. Okay, so we're definitely not looking at a white pixel, we're looking at one of the red pixels in the middle of that little miniature picture. So all of this is telling me is that, yes, mini.pixels array is working, which is really good. Okay, we happen to know that there are pixels.length, number of items. Oops, sorry, not the amount of green. Pixels.length, number of pixels inside of that graphics layer. So 5,600 individual colors. Now, why are we doing this? Well, we're doing this because, like I said, we want to kind of use that little tiny picture as a starting point for a bigger artwork. To make that bigger artwork, let's start by, in our void draw, we're going to get rid of our image. We're going to leave our background in there. And what do I want to do? I want to draw a for loop. And I want to do a nested for loop that's going to draw an XY grid of shapes. Okay, so let's do that. A little refresher if you're fuzzy on this, right? For loop, let's say for open parentheses, make a new integer, not I, sorry, let's do x equals 0. X is less than, and what do I want to do? I want it to use the same width that we have in our P graphics layer, 100 of them. So x is less than 100, semicolon. X plus plus. I'm going to close the parentheses, open a curly bracket, drop down 2 lines, close the curly bracket. So that's a single for loop that will run 100 times. And if you have a different size, if your P graphics, if that's 43, please put in 43 as that number. Okay, so these are correlating. Now inside of that for loop, I want to kind of have a loop inside of a loop, also known as a nested for loop. So I can do that. I'm just making sure I'm inside of the old curly brackets. I'm going to make a new one, for int y equals 0, semicolon. Y is less than 56, because that's the height of our P graphics layer, semicolon, y plus plus. Close parentheses, open a curly, drop down 2, close the curly bracket. Okay, anytime you want to auto indent, Command T on a Mac, Control T on a PC, and it'll kind of get your spacing nicely arranged for you. All right, guys, we're doing really well here. Why? Well, because we have the makings for a grid to be kind of, let's see, what should we do? Let's do let's do rectangles, okay? Remember, a rectangle wants X position, Y position, width, and height. So the X, I already have some X's here, and I have Y's here. So I'm going to use X and Y. I'm just checking out the size of my sketch. Looks like it's 1200. So I'm going to say for the rectangle, I'm going to take the X, and I'm going to multiply it by 10. Right? So for every X, 1 to 100, I'm going to multiply it by 10. So the very last X should be at 1,000 pixels over, right? Because 10 times 100 is 1,000. So, okay, that's good for the X's. I'll do the same thing for the Y. Y times 10, great. And now I'm also going to say each one of these will be 5 pixels wide, 5 pixels tall. Nothing too fancy. Great. Okay, so let's see if I get a big grid that's 100 columns in the X, 100 rows in the Y, or 56 rows in the Y. Whoa, yes we are. Okay, that's a lot of little dots, but this is good. Now one thing I do suggest you do is you keep those numbers that you have in your for loops, and let's just translate the whole double for loop, the whole nested for loop. We're going to just move the whole thing over to the right and down a little bit. This is a perfect time to use translate. Translate wants an X and Y number, and I'm just going to say for now, how about 60 over 60 down. I rerun that. Okay, At least now I can see this top left edge, which is kind of good. I want to make sure that's all visible to me. All right, good. So now, what do I really have? I've made a grid that's the same size in units as I have pixels in my tiny little painting picture, my watercolor picture. So the interesting question is, can I set the fill color for each of these rectangles to be the same color as my pixels array? Ooh, okay, every time you set a fill color for a shape, you want to do it before you draw the shape or above the shape. So I'll set the fill here. And gosh, I know the colors are stored in mini.pixels, and it's an array, so I'll open a square bracket to open up the array and grab something out of it. And let's see, the array is a one-dimensional array. We talked about this in the last video, but it's a long line of things. But we came up with this little fancy formula, right? It was y times the width plus x. So could I set the fill color of this to be y times the width of my P-graphics layer, which is 100, plus x, close parentheses, close square bracket, close parentheses, semicolon. All right. The question is, will this work a little bit backwards from how we used it in the last video tutorial? Last video tutorial, we used this to kind of grab our mouse position, click somewhere, and kind of grab and set that fill color. We're doing the reverse now. We're kind of making a bunch of shapes and using the X and Y grid to see if we can get the right colors. Oh, mama. Okay. Now, if you blur your eyes, you might start to see a shape, right? What are we seeing? We're seeing a poppy, right? It's a watercolor of a poppy. Okay. Let's make these a little bit bigger. I'm going to make them kind of giant. And let's also say no stroke for now. That takes away the black line around each rectangle. Okay, no stroke really kind of makes it look like a blown up image. For those of you who are a little more advanced, we spent a decent amount of time talking about the push and pop matrix and the way to be able to do things like rotate a rectangle using the push and pop matrix. So I'm going to kind of do that here. I'm going to put this whole rectangle inside of a push matrix and a pop matrix. Oh, poop matrix. I can't tell you how many times I've written poop matrix, and the 10-year-old boy in me just laughs every time. Okay, so the pop matrix and push matrix. I've got the rectangle inside. What does that really mean? What this means is now if I were to do a translate inside of the push and pop matrix, and I were to kind of cut out the X and Y position of the rectangle, put it in the translate, like so, and then now I'm just going to draw the rectangle at 0 and 0, like this. I've just kind of added one more phase, but remember this moves the origin point over, and then the rectangle gets drawn. Okay, so let's run that. Okay, so everything looks the same, which is good. That's what we want. But what we now have the ability to do is to rotate some of these. So let's see what happens if we rotate these by radians. This will convert degrees into radians for us. And let's put the number of degrees as being, I don't know, x degrees. That'll be interesting. Let's see if this is going to go crazy or not. All right. Nice. Now, look what's actually happening. It's no longer looking like the same image because each rectangle being drawn is rotating one more degree to the right. And so we're kind of getting into some cool territory, I think. We could say x times 4 to get more rotation. Right? We're getting some kind of swirling of these rectangles. And think how different this is than just taking this into Photoshop and manipulating objects. We're doing some other kind of fancy things. So the whole point of this process is to remember that we're just drawing using a tiny little picture with a tiny bit of color information. We're absorbing it into its own p-graphics layer. That's the one I called mini. And in that little new mini layer that we made, it's the same size as our little mini picture. We did begin draw, we drew the picture, we loaded the pixels into this mini pixels array, and then we ended the editing of the mini p-graphics layer. At that point, we don't even ever have to draw. In fact, we never do draw the mini layer in void draw. We're just using it essentially for that piece right there, which is to load in that pixel information. Now what I've done is I've kind of made a for loop that's kind of using that information, and it's, how would I put it? It's using that information and just kind of extracting the color information out and to kind of blow this thing up to make bigger shapes, right? These rectangles could be huge, long streaks, and just look how, I don't know, it's kind of gorgeous. I really like it. Some kind of stunning things that we can do just by playing with different options here. I should note that because this is a processing sketch, right, any number can be replaced with another number. So, gosh, I don't know. What if I were to add inside of the rotation frame count? That's a number that's growing and changing. Say what? Look at this thing rotating around. See, I didn't even plan on doing that. I didn't know it was going to do that, but now that it's doing that, I think I love it. I think this is my new darling. Okay, so I guess the point of this isn't for that I want you to do exactly what I'm doing. I want you to just start to experiment with thinking of, okay, I've got this pixels array and I can use those colors for whatever deeds that you want. As an example of that, let's say we don't do all this kind of rotate stuff and rectangles. What if you just want to use text? Okay, what if I want to draw a piece of text and I want these all to be the ampersand symbols? Right, now notice I just kept in the translate business here, but what is it going to do? This text is going to adopt the same fill color, so it's going to still use all the same things that we just did, but now I'm going to see this, I hope, yeah, here now I'm seeing the poppy as a series of and symbols. They're all evenly spaced because I told it to draw on a grid, so that's not too surprising. But yeah, I mean, we've got vector colored shapes here. You could do a lot with that as well. So feel free to play around. Just to dork out one more time. Let's see if I say text size, the size of the text I'm about to draw. I'll leave them as ampersand symbols because those are pretty looking things. But let's say I set the size of this to be, we're going to use the noise function. So we're going to get some variation in size. I'm going to say noise of x. Before we've taken the noise of one number, here, there's actually something called 2D noise, which is kind of cool. So I can say x and y. This makes it like a plane of noise, or like a picture of noise, if you will. And remember, noise is only something between the number of 0 and 1, the noise of any number. So I'm going to just multiply this by, 15. So now this is 0 to 15 in text size. And then I'll just add plus that, just another 5. And the reason why I did that is if this number became really small, like 1, the text size of 1 is almost imperceivable. But I can always have this kind of baseline of 5 as the minimum, and then I'm adding to that whatever variation there is in text size. So let's see what we get. Okay, cool. Yeah, if you look closely, we're getting some variation here. It's looking good. So that's a nice thing. Okay, to take this one more crazy level is what if the brighter the pixel color, the bigger the text size? Okay. There's this really nice thing. Remember, we're grabbing the color information of each pixel with mini.pixels, and then just remember that same little formula we talked about. So that's a number, but that's that crazy like negative number. There is a something, remember how we were extracting red and green and blue colors out of a color? There's something called brightness that we can extract out. So I'm going to kind of put in the word brightness, which is just like a grayscale representation of any color, and asking you how bright that is. And I'm saying the brightness of the individual color of the text that we're about to draw. This is essentially going to be between 0 and 255. So let's see what happens. It should be kind of funny. Some big ones. What the hell? Beautiful. Look at this. These are all ampersands. Some of them are so big that we're getting this kind of chopping pattern, which, to be honest, is, again, beautiful. Really a lot to work with there. If that's a little too dramatic, I could take that whole size, brightness value. So I probably want to go between these two closing parentheses. So that would be kind of after this. This is 0 to 255. Okay, if those were all too big, I could divide it by 3.0 and rerun that. And now they're all going to be a third of the sizes that they were before. And I'm starting to see more ampersands in the kind of center of this. So anyways, I could go on forever. You probably don't want to listen to my voice any more than you have to. So hopefully that gives you a good starting point. Play around with these nested for loops and combining them with the P graphics layers pixels array. And I'll tell you, you're going to be off to the races. One more little nugget to send your way is everything you're drawing right now is rasterized as pixels, which is okay, but kind of sad if you want to print this, right? Guess what? There's a PDF renderer in processing that will allow you to save all of that content that you're creating now. And if you're doing anything with rectangles or geometric shapes or text, it'll save that out to a vector format, which means you could print it large, and yeah, you can go wild. So I hope this helps. Again, my name is John Park from the Art and Technology program at the University of Oregon. Enjoy processing and the pixels array.